So we are working on examples of finding the derivative. So the next example that I have is find the derivative of h of x when it is equal to 3 times the square root of x. So I've worked through a couple of examples of this. I suggest that you pause the video and work through a couple more examples on your own. Okay, the first thing I'm going to do is switch my notation over here on the right. Every time I see an f, I'm going to replace it with an h. So I have h prime of x is equal to the limit as h goes to 0, lowercase h, of h of x plus h, sorry about all the h's here, but we'll get it figured out, minus h of x all over h. So capital H's relate to my function, and lowercase h's, we know that's part of the formula. So again, my three-part process. My first part is my function of x plus h, where I just substitute in x plus h into my function. So that gives me 3 times the square root of x plus h. I cannot do anything to simplify, so let's move on to my second step, which is this whole difference quotient here. So this is my x plus h function minus my original function all over h. That gives me 3 times the square root of x plus h minus 3 square root of x all over h. Now we know that we have to simplify this to get rid of this h in the denominator, so I can move on to my third step, which is the limit. Now you might think that it's really easy that I can just separate these two square roots out and my square root of x's cancel out and I can go from there. But that's not true. I cannot separate this square root here by addition or subtraction. So I cannot do it that way. So let's think about it. What happened in limits when we had square roots and I had 0 over 0? What process did we use? The process that we used was we rationalized. So we're going to use that exact same process here. 3 times the square root of x plus h plus 3 times the square root of x. And if I do it in the numerator, then I have to do it in the denominator as well. So I FOIL these out. First is 3 times 3, which gives me 9, times the whole quantity of x plus h. Outside, 3 times 3 gives me 9, root x plus h. Inside, a negative 9, root x plus h. And last, a negative 9 times x. In the denominator, I'm not going to multiply anything out. I'm just going to write down what I have left. So the purpose of rationalizing or multiplying by the conjugates is so that things cancel out, and that's what happens here. So in the numerator, I distribute this 9 here to give me 9x plus 9h, and then I subtract my 9x over here. Just rewriting the denominator from step to step. And hopefully you can see what cancels at this point. So clearly this 9x and this 9x cancels. But not only that, once I get rid of those, my h divided by h cancels. And so that leaves me with 9 over 3 times the square root of x plus h plus 3 square root of x. And so that means I get to move on to my third part of my derivative, meaning I need to take the limit of this as h goes to 0. This gives me 9 over 3 times root x plus 0 plus 3 times root x. Or 9 over 3 root x plus 3 root x. I just add my coefficients, gives me a 6 root x. I can reduce this 9 and the 6 by 3, which gives me 3 over 2 root x. And so therefore, we have the derivative of this function. So my final answer here is h prime of x equals 3 over 2 root x. And so now we not only know how to take the derivative of it, but let's actually apply it in an example. So my purpose of this is to show you the different way that the homework can be asked. So basically, it just tries to reword it for you so that you think it might be asking something else. But in reality, it's all asking the same thing. Compute the derivative of the given function, which we just did in the last step, and find the equation of the line that is tangent, meaning finding the equation of the tangent line, to the graph for the specified value of x equals c. Now again, that's just new language to try and confuse you. So basically this is saying find the equation of the tangent line when your x value is equal to this value here. So don't get confused, why is it using x's, why is it using c, so on and so forth. Just note that that is the very specific point that we're looking at. Now, in my last video, I split up the parts to show you the equation of the tangent line. In this video, it's basically just one big question, but we know the parts. We know in one part we're going to have to find the slope of this line. In another part, we're going to have to come up with the y value of this line. And the last part is actually coming up with the equation of this line. Parts 1 and Part 2, you can do in any order. So if you find the y value before the slope, no big deal. It's all going to give you the same equation here in the moment. So my slope. I do that by using my derivative, which we just found that h prime of x is equal to 3 over 2 square root of x. So all I have to do is plug in my typically x value, in this case our c value. So I just plug that in for my x's. So that gives me 3 over 2 times the square root of 9, or 3 over 2 times 3. My 3's cancel out. So my slope at this very specific question is 1/2. So my slope is given by our derivative. The second thing we need to find is our y value, and we compute the y value by using the original equation. So h of 9 is going to give us our y value. Give me 3 times 3, or just 9. So that gives me my y value, or if you care, that gives us the ordered pair where my x value is 9 and my y value is 9. Now we can use either one of our formulas, y equals mx plus b, or y minus y1 equals m times x minus x1 to come up with the equation of this line. So I have y minus my y value, which was 9. So this is our y value, equals our slope of 1/2 times x minus our x value of 9. So this comes from our x value, which is actually given to us in the original problem. All we have to do is simplify this, and that gives us the equation of this tangent line. So y minus 9 equals 1/2 x minus 9/2. If I were to add 9 to both sides, or in LCD format, add 18 over 2, that gives me the answer of y equals 1/2 x plus 9/2. In the last video, I showed you how to check all 3 of these parts by using your calculator, and I always encourage you to do so. Why not guarantee yourself a correct answer? So I'm going to do that, but I'm actually going to check part 3. If that matches up, then I know that part 1 and 2 should match up as well. So in my first equation, I just type in my original equation. So 3 times the square root of x. In my second equation, I type in the equation that we got for our tangent line, which was 1/2 x plus 9/2. Let's go ahead and graph this on the standard window. If we need to adjust it, we will. So the blue is my original equation, and the red is my tangent line. Now, we were looking specifically at the value x equals, or the problem gave us c equals 9. So we're looking at this value right here. If we trace that up to our graphs, we're looking at this value right here. It does look like it intercepts at those places, and it does look like it has the same slope as those places. Now, if you don't think that this is a good picture, I encourage you to change the window. That's no big deal. Let me go ahead and focus on just the first quadrant. So my y min was 0, and let me go ahead and extend that out farther. So my x max is doubled to give me 20. Same thing with my y's. Let's keep my y min at 0 to keep me in the first quadrant, and let's just extend my y max to 15. It doesn't need to grow as large because this function doesn't grow very large. So again, the blue is my original equation, and the red is my tangent line, and we're checking at x equals 9. So if you want to check it specifically, you can either type the trace value and type in 9. That's going to give you, do you have the right y value, which we do. Or second calc number 6 is going to check the slope. We type in 9, and that gives us 0.5, which tells us that our slope is correct as well. And that, again, tells us where these two lines should be intersecting, and that is the correct point right there. So we've got everything correct for this example.